Well, welcome to the Makerspace wiring network cables, part 2, or wiring cables part 2. This time we're going to look at what are known as network cables. Sometimes people talk about RJ45, which is the name of the connector on the end, this little thing. Sometimes people talk about cats, lots of cats. There's lots of different sorts of cats. Why is this not working? Sorry, I've got something slightly
bad network cable.
Weird going on here. But let's see cats. There we go.
Oh yeah.
That's working. So
the tabby connectors, are they?
so you might hear these things referred to as Cat 5, 5E, 6, 6A, 7, 8. There's different levels of this stuff, and the cables. I've got a cable here which is one. There's this sort of cable is quite stiff, and there's another one here with different cable which is a little less stiff, more flexible. We're going to sort of introduce you to all these different cables and different cats. So for a long time everyone was using a thing called Cat 5, which was the standard, which works at 10 or 100 megabits per second. Then people wanted to go faster than that, so they made slightly better cable, Cat 5E, which works up at 1,000 megabits per second. This is over 100 metre distance, so if you've got 100 metres of cable, which you can generally buy a reel of 100 or 200 metres. But it's very clever stuff, this. I'm always amazed at how this works, because you've really got different signals travelling along these different twisted pairs, and the only thing that stops them getting all messed up with each other on this wire is the fact that they're just twisted at different rates. And you can see there, the brown one is not quite as twisted as the orange one, and the green one is not quite as twisted as the blue one. The rate of the twist is I should show it here so you can see it on the thing. On the right bit. So yeah. So the rate of the twist is what makes this thing work for each different sort of signal. So all those signals are kept separate, even though they're all right next to each other, by the fact that we're using twisted pairs, and the twisted pairs have got different twist rates on them.
So, when did that get introduced? Because that wasn't on the original Cat cable. It was Cat 6 when they started doing different.
No, it has been all the way through, because this is a Cat 5E cable.
Okay.
And Cat 5 had it as well.
Oh right.
I think it came in with Cat 5.
That made them. Because everything before that was the original communication for telephones, wasn't it?
Yeah, yeah.
Cat 1 through 4.
Yeah.
Not network.
So why does it have so many wires? Oh, it's not. Got to choose that. This isn't quite working the way it should have been. Not sure why.
That sounds like technology.
So there's two sorts of cable, as I mentioned. Some are stiffer than others. So this is fairly flexible. This piece. This is stranded cable. Then there's another sort that is solid cable, and you can see this is a bit more inflexible, as it were. So let me just do for the camera. So this one very flexible. You can move it around. Oh, it's not on the right screen. Okay. So you can move it around. Goes around corners quite easily. This sort is solid cable, and the strands in there, each of these are little solid wires rather than twisted twisted thinner wires. So this thicker cable or less flexible cable is better for running around the walls of your house if you're putting something inside the walls to connect two things up. And you need a special connector to connect to, you know, those wall type connectors, but you then need a special tool like this one. This tool has the ability to push those wires into the slots in the socket at the back, and it's quite a complicated little tool. It's not that expensive because they're so ubiquitous, you know, lots of companies have to have one ready to wire up things. It's got a little pair of scissors on the end which chop it off at the right place. But these more flexible cables are better for lost my cable now, what is it? That one. These are better for just joining up two bits of equipment. So this is stranded stuff, but they need one of these special RJ45 connectors. And you probably go out and buy a cable quite cheaply. I mean, I think they sell them in Asda nowadays, surprisingly enough. But what I find is quite annoying is these little clips on the end, this little clip here, quite often get broken off and then the cable's useless. So that's what happened with this cable, which is why it's being used for this demonstration, because basically I'm going to put a new plug on the end of this one, and that should mean that I can then use this cable again. And again, you need a special tool to do it. This is the tool. It can be used to put this one's quite clever. It's got the telephone style sockets on as well, though I don't know anyone who's using those anymore, but I'm just having my telephone taken out, so but this will do both sorts of sockets. So you get these little connectors. This is the little packet of the ones for the telephone, and then this is the size for the network cable, and we're going to put a new one on. Now there's two sorts of these connectors, and I would recommend you don't get this particular sort. The difference is that some of them have holes in the front, and you say, well, why would they need holes in the front? Well, it makes it a lot easier to connect them up, because all you need to do is push the cable into the right places in the connector, and it will come through the hole in the front, and then you can chop it off afterwards. It makes it a lot easier to connect it all up, because if you get the cables in the wrong place, then it isn't going to work. So one of the things that you might have to worry about is what is the right place. Let me just jump around here. So here's your cable with the different connectors, different colours. You have to get the right colour in the right hole. And like all good things, the nice thing about the standards is there's actually three of them. There's a standard called T658A, which is marked as the preferred option, but almost nobody uses it. Most people use T568B, which is the most common one, and I've never seen USOC. I don't know why there's three, but like all these things, it always gives you an extra thing to make a choice. So if you look very, very carefully at, I don't know if we can see this. Just turn it around. So yeah, if you look very carefully in here, I don't know if we can get it to focus that close, but you can see you've got to try and get the colours in the right order. And if we look carefully, we might even, if I turn this round perhaps, got to try and compare this with that one, and you can see actually it's got the orangey ones at the top, if you look very carefully. So that's this one, T568B. And you'll find if you buy anything, it's almost always 568B. So if you do if you make your own, I'd suggest you try and stick to 568B so it matches everything else. But as a tip, sometimes you might want to connect two computers together and you want what's called a cross cable. You can buy cross cables, but they don't sell them in Asda because it would just confuse too many people. But if you want a cross cable, just make one end T568A and the other one 568B, and that makes you a cross cable. So then you can plug computers directly to each other without having to have a network switch in the middle or a hub in the middle, and they'll talk to each other quite happily then. So we won't do that tonight, but well, you can do it tonight if you want. The diagram's there. A little bit more before we start actually making things. I'm going to go back over here. What are actually all these wires doing? And originally with the 100 base T, which is 100 megabits per second wire, this is how the signals were assigned. So two of the pairs were designed for going one way and two of the pairs were designed for going the other. But you'll see here the blue and the brown weren't actually even used. So you go, well, what's the point of that? Well, there were other reasons for having that's on the B version. On the A version, it was the blue and the brown again not being used. So let's see what they might have been used for. There was a system which some companies were using where they wanted a computer and a telephone on the same desk. So they would have the telephone connected to pins 4 and 5, and the so then they could mix the 100 base T and the phone. If you're using 1,000 megabits per second, then what it does is it actually can only run that cable at 500 megabits per second. So it has to send half the signal down one of the pairs and half the signal down the other, and then reply in the other direction again. So that's the other thing. And then the other mode that it could operate in is what's called power over Ethernet. And this is quite an interesting thing to know about for us, because we might want to use this to drive a Raspberry Pi somewhere at the other end of the building, but we don't want to have to plug it in separately. So you can now buy a little board for a Raspberry Pi, power over Ethernet or PoE board, which you can put onto your Raspberry Pi and then feed the power down the spare two connectors, two pairs. So that's done at 48 volts, and the little board downs that to whatever the equipment at the other end needs. So if it's a Raspberry Pi, it will need 5 volts. There's a little converter that will do it for you. But that means that I've got a plan to use that. For example, my garden, I'm going to run Cat6 cable out to my garden shed, have a Raspberry Pi sitting in the shed to do various things with, and I'll run it remotely over using power over Ethernet. So I'm going to leave this up on the screen, this picture, so we can see as we're wiring the plug what we need to do. And I'm going to go back to having the camera on again, so you can see. I'm just going to cover up the A version a little bit, because we're not going to do it to A, we're going to do it to B. But let's see if we can put a new plug on the end of this wire. So I'm going to use the version, I don't know if you can actually see that, but this is the version with the holes in. So it allows you to push the things through the holes and check that you've got the right things in the right holes. This is the fiddly bit. So what we need to do, looking at the 568B, we need the orange one to be the ones at this end. So holding the connector with the gold thing up. So this way up. So you're looking at the gold connector. we need the orange to be this end. So at this end here. And then the next pair are separated, so you have a green and white, and then the blue and white, green, and then the brown pair go together. So the first thing to do is to unwind these wires a little bit. So they're all wound up. If you're wiring something, you're not really supposed to unwire them, untwist them, because the twist is important. So, but you have to untwist them to put them into the connector. So we untwist them as little as possible. But in this case, I'm going to push the connector right up to the end of that wire, so I can untwist them all the way back. If you are connecting to one of those wall sockets, then you should only untwist the wires as much as as little as possible. So if you can avoid untwisting them, it keeps the signals running down there properly. Oh, I just got this other connector I was going to show you. This is the way we used to do connections. Lots and lots of soldering there. We don't have to do any soldering to do this. It's all done with a crimp connector. So I get all these things untangled, and so we've got to, on the very outside, we've got the orange, the white and orange, then the orange, and then the next one is the green and white. So let's tease that out. There's the green and there's the green and white. I'm not quite sure. Anyone who's colourblind might have trouble with this stuff. And the brown's going to be down that end. Then let's find brown and white. Blue goes next to the green and white, yeah. Then there's the green, and there's the, so I've got them roughly in the right order now, and I've got the job of feeding them into the thing. Now, one of the things I've discovered in doing this is it's quite often a good idea to cut these back a bit. So I've purposely made these a lot longer than they need to be, and that way I can chop them off a bit, and that makes it kind of easier to feed them in. If I make them like full length at one end and then slowly make them shorter and shorter as they go through the thing. So I do that, which just makes it easier to put them in. And with these connectors, because the wire's coming out, it doesn't matter that they're all different lengths. You can't, if you're using one of those other connectors where the wire won't go all the way through, then you've no choice but to make them all the same length, which is a pain in the to say the least. But as you can see, once you feed them in, that they're in. But immediately I've got them the wrong way around, so let's get these the right way around. So it's white and orange first. And can sort of get those in. And then, actually I should have probably got a pair of tweezers. So the next one to go in is the green and white, so try and feed that in. And if I finally got them, I think, all in the right place. So let's push it all the way through and then check. So we've got brown, it's going backwards, brown and white, and green, blue and white, blue, green, white, orange, orange and white. So you can see now they go, yes, I hope you can see, they go all the way through and they're coming out in the right order. And if we had a boot on here, we'd then push the boot off and use some sort of hot gun to melt it into place. But now we're going to use the tool. So it's got two, this particular tool's got two holes, one for the 8 core version and one for the so one's got 8p written on it, one's got 6p. We want the 8p version, and we put it in so that this little lip here goes into the slot. So all those wires need to go through that hole, and then it sits in there in the tool so it's snug, and then we give it a squeeze and all those little metal things go into place, and hopefully that is now snugly on there, and we can now chop the spare wire off. In fact, I think on this tool we've actually even got a little gadget for doing that. With a sort of sharp.
Hello.
You know,
Hello.
put on
Good to
this
get
one.
her a lot earlier rather than at the end.
Do come in.
How's everyone?
We're just having a demonstration of wiring up Ethernet cables.
So then that's chopped the end of those off.
But you've come back
Nice
pretty
and
much at the end of the demo, so
Yeah.
And probably what we should do now is test it, but I've got a little test box, but I've mislaid it at home. So what you do is basically plug that and the other end of the wire, the two ends of the wire into the test box, and it will go through and make sure that the
that they're
each of those
connected in the right
connections
places.
goes through to the right end,
Mhm.
which I'm hoping they do. Looks like there's certainly a wire in each one, but whatever. Thank you very much. Sorry,
Thank you.
sorry
Thank
it was
you.
so painful.
It's very realistic though.
Very realistic,
Yeah.
yes.